All right, so we're starting chapter 2 today. We're going to talk about functions. A lot of this stuff will be reviewed today. There's a couple of stuff that's maybe a little bit new, but bear with me, and if you have any questions, let me know. Functions. A function assigns each member of the domain to exactly one member of the range. That gives us our points, like 1, 4. Part of that is our domain. Part of that is our range. The domain of a function is the set of all the x coordinates on the graph, the independent variable or the input. You might be able to guess what the next one is. The range of a function is the set of all y coordinates on the graph, the dependent variable or what we get for the output. So you've had those told to you about 1,000 times. If you're having questions, you got to figure it out now. The zeros or roots of the functions or the x-intercepts of the graph. So if I give you an x-intercept, that's a root or a zero. And then a relation is a set of ordered pairs. So you know we can have functions. We don't have to have functions. If it isn't a function, we call it a relation. Well, you'll see. Function notation. F of x equals 3x minus 5 is essentially the same as y equals 3x minus 5. So f of x is a different notation. If they gave us, say, f of 3 equals that equation, that means we plug in 3 for all the x values. The way you know if you have a function, a couple of ways. F is the name of the function, and the f of x is the y value in the output for a given. And let me rephrase. F of x is the y value or the output for a given x. And remember, your x's cannot repeat. And we'll look at some here in just a second. This is really the big thing from that whole part. For the following relations, identify the domain, the range, and whether or not the set is a function. So the domain, the first thing we're going to do is list these in increasing order. So when you do this, use increasing order. I want the smallest number first and the biggest number last. And in this one, don't repeat. If we've already used -2, we don't need to use it again. So if I look at the first one, the domain, I'm going to open up my brackets, and I do need to see those brackets. It looks like the smallest x value is -8, so that's where I'm going to start. Then I can go to -5. I'm going to kind of mark them off as I go. Looks like -4 is after that, and then -3. I have two -3s. I'm not going to repeat. I close my brackets. The range. Now the y values. Let's see, the smallest y value is 0. I've got a 1, a 2, and a 6. And notice I didn't repeat the 1 because I'm not using repeats. Is this a function? Well, here's where it can get tricky. Look right here, -3, 1 and -3, 0. If that were true, I would have to be able to plug in a number to the same exact equation and somehow get out different numbers. This means it is not a function because we cannot repeat the x values. Let's look at number 2. I start with my x values in an increasing order: -6, -5, -4, -3, -2, -1. And I close it up. My range, the y values, let's see, it starts at 1, then 2, 3, 4, 5, and 6. Is it a function? Yes, it is. There are no repeating x values, so everything works out for us. All right, let's look at the number 3. The domain. Let's see, I've got a -5, -1, a 2, and a 3. And then on the range, they're all 5. Now, whether you like it or not, this is a function. The x values did not repeat, just the y values. If this were a graph, it'd just be a horizontal line. Let's look at the next page. So now we're going to find, in order for the graph to be classified as a function, it must pass the vertical line test. We'll talk about that when we get to one in just a second. Then we're going to find the domain, the range, the zeros, or the, let's remember, x-intercepts. We'll decide if it's a function. So the domain, you've got to remember, domain is the x values. This is from left to right. So I'm going to come over here, and I'm going to put a little mark as far left as my graph goes. That's as far left as it goes. This is as far right. Okay, remember these are x values. So let's see. 1, 2, 3, 4, negative 5 is how far I went over here. 1, 2, 3, 4, 5, 6, 7 is how far I went over here. So my domain, I'll start with my low one. It is a closed point, so less than or equal to our x value. Another closed point. Oh, I'm sorry, it's an open point this time. Get back there, so it's not equal to as well, and that would be to 7. You're always going to have this in the middle, pointing in those same directions. The only thing that'll change will be the equal signs. Range, I can go ahead and write this on range. Change to red. Range is your x values or your bottom to top. If I come into my graph, my bottom most is here, at negative 1. My top one is here, it looks like at 5. I'm closed at the top, opened at the bottom. So I have negative 1 is less than, y is less than or equal to 5. The zeros, let's find the x-intercept. Looks like it's right here, 1, 2, 3, 4, 5, 0. And then is it a function? So here's the vertical line test. If you don't remember, let me get rid of some of this stuff. It's essentially, can I draw vertical lines through my graph and it only hit it once? Well, obviously that hits it once every time. That hits there, here, 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 and here. That does make it a function. All right, so let's look at the next one. This one's kind of nice. Let's talk about domain. I need to see how far left and how far right this goes. Well, that arrow means that it continues going in those directions forever, meaning the domain is all real numbers. The range is a little different too. Like we talked bottom to top. Well, I can't tell how low I can go, but I can tell that I'm up here at 6. So remember that line is all our y values. So I don't have two values this time. I just have a top. I know that y is related to 6. So we just need to go less than or equal to or greater than or equal to. So if I notice everything on the graph is below 6, then y is less than or equal to 6 since it's a solid point. Then I can easily find my zeros or my x-intercepts. I've got one at negative 4, 0 and one at 4, 0. I can do my vertical line test. I'll change colors here. You can probably do it without drawing them. None of them touch it more than once. Yes, this is a function. Let's go to this next one. This one's the most complicated. Here's what I'm going to do to kind of help myself out. I can see that it has a left, right, top, and bottom. I'm going to go ahead and write this on my domain and this on my range. I'd give you some points for that. It goes all the way over here to 1, 2, 3, 4, negative 5 to the left. 1, 2, 3, 4, 5, 6, 7 to the right. They're both open dots, so I don't need to put any equals. Negative 5 is less than x is less than 7. Let's look at the y values. Looks like I'm down here at negative 3 and up here at 1, 2, 3, 4, 5, 6. At negative 3, it's open, but at 6, it's closed. So negative 3 to the left, 6 to the right. Our zero is pretty easy to find. Looks like I've got one here at, let me count, 1, 2, 3, 4, negative 5, 0. Looks like another one at 2, 0. Didn't really mark it perfectly, but there it is. All right, is it a function or not? You can probably tell without drawing the lines. It is a function. And then the last one. I think this one's actually pretty easy. So I'm going to go ahead and write my little things for domain and range. And x values. It looks like I go all the way to negative 4 to 4. They're both solid, so negative 4 is equal to 4. The y value also negative 4 to 4. Also equal to. Zeros, it looks like I've got two of them at negative 4, 0 and 4, 0. And this one, if I draw that straight line, it crosses the circle twice, not a function. All right, so these two problems are a little bit weird, okay? The first one's not so bad. The second one is a bit strange. So be really careful when you do these. This is saying here is the domain and range of something. I want you to sketch it. So the easiest thing to do is to find the corners of where this could exist. I know I'm going to have a corner at 3, 1. And I know I'm going to have a corner at 3, 10. But I'm also going to have a corner at 7, 1 and a corner at 7, 10. So I just kind of mixed and matched the X's and Y's. I'm just going to kind of put some things where those are. 3, 1, about right here. 3, 10, way up at the top. Then we have the 7, same thing with 7, 4, 5, 6, 7, about here and here. So what I'm going to do is kind of dot that in. The graph only exists inside that box. They're all going to be solid points because these are all equal to. So let's just draw something and see what happens. What if I start down here at the bottom with a solid? Let me change colors. And I end up here in the corner with a solid. Does that meet the requirements is kind of what we want to ask. Well, the domain would be 3 to 7, which is what we want. And the range would be 1 to 10. They're both closed because they're both greater than or equal to. So that one's not very hard, but I'll show you where it is. If all of our, let me erase. If all of our inequalities are the same, it's not too bad, but look down here. Now they're not. One of them is equal to and the rest are not. But it kind of works the same way. So let's find our corners. 2, -1, 2, 6, 8, -1, 8, 6. Let's find our corners. Let's see, 2, -1 would be about here. 2, 6, 1, 2, 3, 4, 5, about right here. Then the same thing's on 8. Let's see, 3, 4, 5, 6, 7, 8. One right there, one right there. So here is where our graph exists. But here's a problem. So you don't write this. Let's say I started it over here. So at 2, -1, I open a point. That kind of gets the requirements for this first part, right? But then what if I just put a solid point up here? The problem is if I connect them, if you look here, it would have to be an open point there because it's not equal to 8. It's less than 8. So I have to rethink what I'm going to do. Now, one way to kind of fix this, sorry, I'm going to have to go back here quite a bit to erase that line. There we go. Is I know I want it at some point to equal 6, but I need it to be below 8 when that happens. So if I make a line up here and then make an open point somewhere here at the end, now let's check the requirements. If I were to just write the domain, I would be, like I'd have my x here, right? I would have just less than, and I would have, looks like 2. And then when I go over here all the way to the other side to the right, it would be at 8. But if I look down at the other side, the domain, that would be at -1 is less than because it's open. It goes to y, but then it goes all the way up to 6 and is equal to it. These are kind of challenging. You just have to think. If you need help with them, let me know. If not, good luck.